Welcome to this morning's stream. This morning, we're going to be talking about functions. We're going to be building on some of the conversations we had in the previous classes. And basically, we're going to be seeing how to write queries that uses built-in functions. We're going to be focusing more on that. So we're going to be looking at the different kinds of built-in functions. We are going to touch on aggregates. So we're going to do just one lesson. And as usual, we are going to align it with our module here. You can see I've gone through the module and I encourage you to do the same thing. So what we are going to be doing is we'll look at the different kinds of built-in functions. We are going to be zooming in on scalar functions, ranking and row set functions, and we'll spend most of our time talking about aggregate functions. We're going to see what that means. I'm going to be following this as much as possible. So as usual, I'm going to be alternating between the Microsoft Learn module, the SQL Server Management Studio to run the scripts, and the slides just to give us some pictorial view of some of the things we are going to do. So what we are going to be talking about here will be, we will categorize built-in functions, we will use scalar functions, ranking and row set functions, aggregate functions, and all of that. So basically, you can see here that it's just telling me to complete the module. And that's because I've gone through the entire module. So I'll just use all of this to toggle between the different modules. So let's see what we will be doing. So now basically, SQL Server gives us a lot of built-in functions. And what these functions do is that they allow us to be more flexible when we are writing queries. And the functions are grouped into different types, like you can see on the screen, and each of them serve specific purposes. Now, these functions will basically have one aim, and that aim is to simplify our queries to allow us to do some more complex things. We're going to just look at an overview of each of them, starting with the scalar functions. Scalar functions, basically, from the name, will return a single row. Of course, from the name, return a single row, which is based on the input. We're going to see that there are different kinds of scalar functions. I'll just list some of them. We've got the length. We've got the get date. Yeah.
There's lag time.
There's some lag. Okay, but at least if you can hear me, you can hear me. So usually when I'm writing, you might see some lag. Okay, but basically I'll try to talk a bit slowly and not talk too fast. So let's see what these functions do. But basically, the first function there is we can see we've got the length function. And what the length function does is it returns the length of a string. What is a string? Just a set of characters. And then the get date function, what it does is it returns the current date and time. And then we've got the upper functions like upper. We've got functions like absolute. We've got all of those kinds of functions. So without talking too much, let's go see what some of these functions can do. Now we can see here, we've got different kinds of functions. Here we see we are using the context of the database. The database we are using is the AdventureWorks database. And we can see that we've selected two columns, the sales order ID column and the order date column. Let's just try to neglect this part of the query for now. And let's basically see what this query does. So basically, the query selects two columns, the sales order ID and the order date column, and it selects it from a table here called the sales order header table. Hello, can you hear me?
Yes, we can.
All right, thank you very much for that confirmation. So see here, So we're just going to, what we are going to be doing with these functions is we're going to be playing around this result set, which is the order date. So what I'll just quickly do here is, let me just open another query column and see what the result would look like. So I'll just copy this query. I'll go to new queries. I'll just paste this, and then I'll go back to the old query and copy this and come back and paste. So here we see that if we run this query, this is what it gives us. It gives us two columns, one column called sales order ID, the other one called order date. And it's going to be giving us that column from a table called sales.sales order header from the AdventureWorks database. So if we execute this, okay, I have to take this out. I have to take that comma out. That comma is not needed there. Okay, so I'll go ahead and run this. We see now that it gives us just two columns. One column called sales order ID, another column called date. Now, if you look at the date column, it gives us some very interesting things. It gives us the dates in the YY, MM, and DD formats, and it gives us a timestamp, which defaults to 0 seconds at midnight. Now, this doesn't mean so much to us. We just see a sales order and the date it was ordered. Now, if we use the functions, we can see that the functions got a number of things. We are playing with the order date column. Now we want to remove from the year the order date as order year. So we use the year function and we want to extract the order date from the year. We want to extract the name of the day from the month. We want to extract the day itself. We want to do a lot of things. So now remember, this is what our query should look like if we do not do any function operations on this order date column, which is this column right here. Now, if we run this query now, you're going to see that it gives us some more informative details. We can see here, if we x-ray this, we can see order date. It gives us, of course, the order date as order year. So it tells us the year this order was placed, and it tells us that the year is 2005. It gives us the order month, which it uses the date name function to give us the order month. Of course, it tells us this, the month from the order date. So what this is simply saying is it should extract the date name, the month specifically, from this column called order date, and it should write it as order month, which is exactly, that's the first one here, sorry. In this case, it's telling you that it should extract the order date from the year and should write it as order year. And for the next one, it should extract the month from order date and it should write it as order month. So this is what the MM does from the order date. So that tells us that the order month is July, and it should tell us the day as the order date. So it goes and extracts day from the order date and it aliases it as order day. So it's telling us that this happened on the first day of the month, and then the name of the date. Of course, here the date that's the weekday from the order date as the order weekday, which is Friday, and the year since. Now, the year since is basically this. It gives us a calculation, of course, extracting the dates. It's telling us that how far away from today's date did this order happen. That's exactly what that one tells us. So we see here we are doing year, we are doing a subtraction, which is the date diff, in years from the order date to this get date. Get date here is the date of today. Okay, so it's saying that this order happened how many years ago from today? And we can all see that it gives us 20 as the year since. So that's one very important use of Scala functions. We can use them to do lots of very interesting things. In this case, we are using it to perform date calculations. Okay, now we also can use some other kinds of functions as well. In this case, we've got mathematical functions. Now, I know that some of us, when we hear mathematics, we become very, very jittery, but the mathematics here we are talking about is very basic mathematics. So we are going to see what this does. Again, the base query here is we are using AdventureWorks. We are selecting a column called tax amount, and we are selecting it from a table called sales order header. So let's see. Okay, I'll just go ahead and run the base query, which is tax AMT. I'll just go ahead and tap that. If we run this query and execute, we see it just gives us tax amount. It gives us lots and lots and lots of, well, details that we don't really know. We might know as database administrators what this means, but don't forget the aim of data analysis is to give your data some human face. If you send a report that includes all of those values to anybody, the person will think, well, perhaps you didn't sleep very well at night. That's why you are doing this. But to make this a lot more functional, if you will, we are going to now be performing some functions on each of this. So we can see we've got the round function, we've got the floor function, the ceiling function, the square root, and the log. So if we now execute this query, we're going to see that it gives us something more meaningful. Though this might not be something you'll use on a day-to-day basis in your organization, but of course we can see here it tells us, first of all, it rounds the tax amount to 0. Of course, we can see here, and then it gives us the floor. We can see here, it gives us the ceiling. We can see all of the details. It squares it. It gives the square root. It gives the log. And of course, it randomizes it. So all of the aim, like we said earlier on, of our function here is basically to give it to give our data more human face. So let's see basically the kinds of functions that we have. We've played with a lot of functions, and let's now go ahead and talk about the basics of what the functions do. Now, like we said, scalar functions are built-in functions. They could also be user-defined functions. What they do is they work on individual elements of a row to return a single or scalar value. So that's the aim. It returns a single value as output. Now, what we'll be using them for is we're going to be using them within SQL queries to manipulate values or to compute values. What they do also is they enhance the functionality of our queries. Like we saw, they make our queries a lot more human, if you will. The result of our queries are more readable to whosoever we are going to be serving the reports to. And they've got a lot of characteristics. One of it is they operate on single row inputs. That's one of the first things we need to know. Because they take inputs from a single row, they're going to perform their operations exclusively on individual elements of values within the row. For example, we saw that the length function is going to calculate the length of a string. So we do a lot of things with the length. If we want to know the length of the string, we will basically use one of the scalar functions of the type length. And that length gives us the length of the string, for example. So that's one. The second thing is they return single values. They return single values, only one value, hence the name. That's why they are called scalar. They return single values. Now, the output of a scalar function will always be a single value. Those values could be numbers when they are numeric. They could be strings when they are characters, or they could be dates. So we need to take note of that. And of course, we saw different kinds, like we saw the get date, which returns the current date and time, and of course, the absolute value, which will return the absolute values, for example. Again, they can also be used like an expression in a query. Now, what this means is we can integrate them into queries as part of an expression, just like we saw. We can use the upper, like we can see. If we go back to our query here, we can see if we run this base query, again, let's go ahead and run the query in the base form. I'll just select this and okay, and I'm just copying this to minimize typing. That's it. You don't have to do that. And by the way, the query details will be in the folder I'm going to share later. So now, if I try to run this query, what this query simply does is it selects only the last name from a table in the Transact-SQL database called employees. So if I run this query, it's going to give me just one result, and that is the last name. Okay, it gives me the last name. We've got 9 records, but I may want to play around with that detail. If I want to say, give me the last name in upper, that is in uppercase only, I could do that. If I say, give me the reverse of the last name, I can do that. If I say, give me the initials of the last name, I can do that. And that's exactly what I'm going to be doing in the next line here. So we see here, these are some scalar functions. If I say upper last name, it's going to display the last name in uppercase. If I say lower last name, it's going to display the last name in lowercase. If I say length last name, is going to give me the length. If I say reverse, it's going to reverse and all of that. So let's see what will happen. If I execute this query, we can see. We see last name, of course, is the base query result. We see upper, it gives it in upper. If we say lower, it gives it in lower. If we say length, it gives it in length. If we say reverse, it reverses it, and all of those kinds of things. So these are some of the things that queries is going to allow us to do if we use scalar functions. And there are lots of other functions, and let's go ahead and see some of them. So we see that scalar functions have a lot of categories. We could have them for configurations, for date and time, for mathematics, for strings, and all of those kinds of things. Now, what we are going to be talking about next is this two big grammar here that says deterministic or non-deterministic. So what do these things mean? Now, deterministic functions will always return the same results for the same input values. They are deterministic. For example, if we use the len function, it is deterministic because the length of a given string will always be the same. It will not change. Okay. Now, there are other ones called non-deterministic. What that means is, of course, you can guess, the result set can be different because it can return different kinds of results, even with the same input value. And one typical example of that will be the get date. Of course, if you run get date today, it's going to give you today's date. If you run it tomorrow, it's going to give you tomorrow's date. If you run it 10 years from now, so that will always give you a different result. Okay. It is non-deterministic because the time is going to depend on the system clock. Okay. Every system has got a system clock that syncs with a time server that allows you to get the date of a specific region where you are. Or, of course, to get the date of a specific region, that's basically how it's done. And then there's a third thing we need to know, which is collation handling. Now, so what is collation? Collation refers to the rule that determines how strings are sorted and compared. So for scalar functions, especially the ones that operate on strings, collation of the output would depend on the collation of the input values that's provided by the function. And if no input values are provided, it will also depend on the default collation of the database. Well, that is going to be, well, a bit above the scope of this. So let's just know that collation has to do with sorting. Let's just call it. It depends on the sorting that has been specified at the time where the server and the databases were configured. Okay, so we have different categories of scalar functions like we see. We have the ones that work on strings like the len. We have the ones that work on mathematics, like the round, which we saw. We have the ones that work on dates, like the get date and the date add, like we saw. Again, to refresh our memories, these ones basically are mathematical functions, yeah? The round, the floor, the ceiling, the square. And these ones are dates functions, yeah? The year, the date name, the day, the date diff, and all of that. And of course, these ones work on string functions, the upper, the lower, the len, and all of those kinds of things. So those are basically what scalar functions do. So moving a bit further, let's go to another kind of function called row set functions. I'm not going to talk too much about this. I'll just define it and then I'll leave it there. It's a bit out of scope. I don't want to get us a bit too, get us into something that is a bit too complicated. So I'm going to, of course, define it and leave it there. Okay. So row set functions basically return a virtual table. So we can use them like a table within a Transact-SQL statement. Okay. And this table will be from the from clause of the query, and they are useful when we query external data. Now, sometimes in your data analysis journey, you may need to pull table from an external data source. And that's one way you will be using the row set functions here. It would include the open data source function, the open query function, the open row set function, and the open XML function. Like right here now, like I said, it's beyond the scope of this course. We have an example here that you are querying all of the columns from an open data source. You specify the data source using the server name, the user ID, and the password, and so on. I'm not going to talk about this, but just know if you see anything around open row set, you know that it allows you to return a virtual table that you can use within the from clause. I'm not going to talk about that beyond what I have said. So let's move on. Now we're going to be talking about ranking functions. Now this can be quite important, as you can imagine. So what do? We want to use them to assign ranks. Ranks are basically positions to rows. Okay. So what they do is they operate on sets of rows and they are non-deterministic. Remember, non-deterministic means what? The results can change if the ordering criteria is not unique. So take note, deterministic means the order, the results will always remain the same. Non-deterministic means that the results, well, will be dependent on specific conditions, so they can change. Okay, so take note that ranking functions, well, from the name, assigns ranks to rows. They will be operating on rows and they are non-deterministic. So these are the core things we need to know. And there are different kinds. We are going to take a few of them. We are going to look at the row number and all of that. So remember, they work on a set of rows. They calculate a ranking value for each row within a set. And they assign ranks or positions to rows based on what is specified within the order by clause. Okay, so these are basically some of the things we'll talk about. And we are going to see different types shortly. Let's go ahead and look at some of the ranking functions we have. Where are they? So we have here the ranking function here. So what this example does is it uses the row number ID, assigning a row number based on descending order of higher dates. So if we come here and select this and execute, but first of all, let's look at the base table. The base table is select employee ID from HR.employee. So let's copy this. So I'll copy emp ID. Okay. So if I select this and execute, we can see it just gives us that. But if we want to give some ranking, let's go ahead and we are now going to have a ranking result set where we are going to be ordering by hire date. So if we execute this, so we can see here the order of the hire dates. We can see while we had just one column, here we have two. So it's giving us an order. In other words, it's going to tell us some ranking, giving us some ranking for the employee ID, telling us it ranks it by order date. So we can see a rank of 1, 2, 3, 4, 5, all the way down to the end. So that's how the row number function works. Okay. Now we could also use the rank function. Now, what the rank function does is it calculates a ranking based on the list price. In this case, the highest price is going to be at the top of the ladder right here. So we can see we are selecting the top 100, meaning that we are going to select only 100 records. We are going to be selecting product ID, name, list price, where we want to rank. So if we execute this query, of course, we can see a rank here. Now, you're going to see something very, very interesting here. And that's because the rank ranks to rows. Okay. But rows with identical values are going to receive the same rank. The next rank is going to skip numbers to account for the type. So we can see exactly that happening. We see the first rank. We can see this gives us, of course, the most expensive product here. We can see this is 1, this is 2, this is 3, this is 4, this is 5. Notice that since we have a tie of 5, it doesn't take the next rank as 2. Rather, it takes the next rank as 6. So we have 6, 7, 8, 9, again, a tie. So it gives us the next rank as 10. And that's exactly what the ranking function does. Of course, you may have a requirement. Somebody gives you a task that he wants you to give a listing of all of the products ranked by the cost of the product. And this is a simple way that you can do that. Of course, there are lots of cases you can do. Maybe you are in an educational scenario, and of course, you have a compilation of all of the scores for a specific subject, and you want to find out who came first, second, third, and all of that. That's a simple query that does that for you, especially if you have number of records in the order of the hundreds of thousands or even in the millions. So that is a typical use case right there. Okay, now apart from row number and rank, we have other functions as well right here. But again, let's look at the rank here and let's see what this one does. This is a more practical scenario. So this extends the previous example, calculating price-based ranking for products in each category. So notice here that it uses a join. So let's see what happens in this scenario. So I'll go ahead and execute. Again, this is querying multiple tables, and we have been able to establish a rank by price. We see we have 1 and 2. Since there's a type for first position, we move to the third position, and then the fourth, the fifth, and all of that example here. And then we've got the dense rank. Now, the dense rank is very similar to the rank. Now, what is the difference is the dense rank skips ties, but it skips ties. So sometimes it might become desirable, or it could be a requirement that we don't want. We want the positions as is. We don't want any skipping of ties, and that's one scenario where you are going to be using the dense rank. Now, this query here using the rank and that using the dense rank is exactly the same. But while the result set you see here uses the rank, this one, we can see we have 1, 2, and it skips 2 to 3. We have 4, 4, it skips to 6 and all of that. The dense rank doesn't do that. So let's go ahead and see what that will result in. So I'll go ahead and click on execute. We can see we have 1, 1, instead of skipping 2, it still goes ahead to give you 2. We have 3, 3. It doesn't skip, it goes to 4. So that's the basic difference. The rank can skip ties. The dense rank does not skip number for ties. That's basically the difference between the ranking and the dense ranking. Okay. And then I think that is what we will be moving on to now. We are going to spend some time here talking about aggregates. Now, aggregates or aggregate functions more specifically are very powerful functions. Now, the aim of aggregates is they operate on sets or sets of data to summarize. So what they do basically is they summarize. Now, if you are trying to write a report to a C-level executive, they usually do not want some of the finer details. They don't want you to analyze the result on maybe a business unit by business unit basis. They want to know that for the entire company, did we make a profit? For example, those are the things they want to know. They want to know if a profit was made. They don't want to say, hey, for each product group, we made 10 pounds, 30 pounds. They don't want to know that. So what aggregate functions do is they operate on sets of data, providing a single value that summarizes everything. Now, sometimes if you do not use the group by clause, all of the rows will be arranged in one group, like we can see in a typical example here, which I'm going to just demonstrate in a minute. So let's go and look at that. I think I did it somewhere towards the top. Okay. So here we have an aggregate function without the group clause, without the group by clause. So we can see we want to select a count of all of the items. We want to call it number of order lines, and we want to do a sum. Okay. In this case, the quantity and the unit price as total sales from the sales order details table. So notice we don't have any group clause. We don't have any group by clause here. So let's see what our result set will look like. So it just gives us the number of order lines and the total sales. So that's how that one will behave. Okay. So we are going to now be moving on to some specific kinds of aggregates. Now let's go and see. We've got different kinds of aggregates. You can see aggregate here. We've got the aggregate of the average. We've got the same list price as minimum and maximum. So if, for example, we selected, let me copy this and take it here. We want to use the Adventure Works table. Adventure Works database, I beg your pardon. And we want to just select the, let's say, list price. All right. So if I execute this, now we see it gives us list price. We've got lots and lots of results here. We can see 504 rows affected. Let's see if that list price. Okay. So this is not a very good example because apparently everything here is telling us 0. Okay, but we have some that is not giving us 0. Okay. So here we might want to find out the average, the minimum, the maximum prices from the column called list price. And that's one very good way to use an aggregate function. So compare this result here, which gives us 504 rows, to the result of this query here, which is going to give us an aggregate of everything. So let's see. We can see it gives us the average price. It gives us the minimum price. it gives us the maximum price. So we can see that for a C-level executive, he's not going to be interested in all of this. This doesn't mean anything to him, but he's going to be more interested in something like this. He knows the average price for all of our products. He knows the minimum price. He also knows the maximum price. So sometimes you might have a requirement to just give a quick summary of the pricing position of your organization. And one of the ways you can do that is you can use functions. You can use aggregate functions that allows you to do this. In this type, we can see the aggregate function of type average, of type minimum, of type maximum, for example. So we can see this is basically the same thing. This is just a repetition. I'll just go over to the next one. Okay, here we can also use a filter. In this case, we have a filter for product subcategory. So we can apply filters to our functions. And if we execute this, of course, we can see for a specific product category, we can find the average price, the minimum price, and the maximum price for that particular product. So we can see here that we use a filter condition to determine the average, the minimum, and the maximum price for a specific product that has a category of 15. All right. Now, again, we can return first and last company by name, of course, using average, of course. So here, using the min and max. So in this case, of course, we use the min, company name as minimum customer, max, company name as max customer. So if we execute this, of course, it gives us this record here, gives us this details here. So we can also, apart from using that, we could also use min and max. And further, we've got other examples as well. Now, in this example, it returns the number of customers that have placed orders, no matter how many orders they have placed. So we are using the count here, and we are specifying the distinct customer ID. Remember, of course, the distinct is going to give us all the customer ID without repetition. So that's what the distinct does. And we're going to be aliasing it as unique customers. So I'll go ahead and run this query. And let's see, it gives us the number of unique customers. And the number of unique customers here is 19,119. And we could also use group by with our functions. So let's see of grouping by. We can use group by here where we want to select the adventure works. We can select the customer ID from the sales order header. I want to group by customer ID. So we are going to do a group. I'll go ahead and we are grouping by. Let's see if we can run it without the group by. Okay, see, there's no group. We are not grouping it by customer ID here. So we are seeing that we've got everything 1, 2, 3 being the same. And here we've got 31,465 rows affected. But if we include the group by clause, we can go ahead and see that we've got, of course, everything grouped, and we have fewer results, fewer rows selected. And then I think finally, okay, we still have a few that we can do. Finally, we are going to be doing the same thing using the having clause. So if we see here, same thing. Let's first execute the query in part. Okay, sorry. Let's execute the query in part. We can see we have an order count, but we can also use having count to filter. Okay. So that's basically it. Now, to conclude, because I promise we're not going to spend a lot of time, to conclude, I strongly recommend that you go to this exercise here and launch the exercise. And we've got a lot of queries that you can use to understand all of the details we've talked about. And then at the end, we have a challenge that you can also try. Okay. And that challenge allows you to test all what we've discussed. And then, in addition to that, there is a video that is available on Microsoft Learn that you can go ahead uh, and also you can go ahead and also listen to the video or watch the video. I'm going to just drop it in the chat, and that's going to help you to further tighten your skills on what we have done. Uh, so I'm going to call it a day here at this point. If you've got any questions, go ahead and drop it in the WhatsApp group or send an email or something, and I will be more than happy to um, attend to your questions. So thank you very much for your time, and see you in the next stream. Bye for now, and enjoy your Easter holiday.
Thank you.